We are live on YouTube and on Teams. Welcome everyone to SQL Friday number 137. We have today Hugo Kornelis, who is going to present normalization beyond third normal form. And I was going to say I have seen this presentation, but I have seen a presentation with this title. Is probably more correct because no presentation is exactly the same 10 years later. I saw it on SQL Nexus in Copenhagen, and it was probably 10 years ago. That was the first time I saw Hugo present, and I really liked it, and I'm really glad that you submitted that session to SQL Friday. So with that said, and I need to switch scenes so we can see the presentation as well. Welcome to SQL Friday, Hugo.
Thank you. And yeah, SQL Nexus is really a long time ago indeed. The basics of the presentation have remained the same, but I think there will also have been changes. Anyway, I am indeed going to talk about normalization beyond a third normal form. I should have done this bit of preparation before. You don't see this, but now I see my preview here. And my name is Hugo Kornelis. Welcome to this session. I make SQLServerFast.com. SQLServerFast.com is a website that I set up because it's not the topic I talk about today, but I love execution plans. I love everything you can do with execution plans, but I hate the amount of documentation that Microsoft has made available about execution plans. Because of that, I decided to start documenting execution plans myself in the execution plan reference, a free resource where you can find insane amounts of very detailed information about everything in execution plans. At the request of some people, I also started recording training videos. Those are partly available for free, partly for a low price. And because I love people who attend my sessions, I always give a discount code. So if you want to buy access to any of my execution plan training videos, you can do that from now until the end of May using the code Friday, how original, and you will get a 10% discount off the already low price. At SQLServerFast.com, I also have a lot of other stuff like my blog, articles, and very important, the resources section. In the resources section, you can find, for instance, the slide decks and demo code for all the sessions I have, including, of course, this one. So if you go to SQLServerFast.com, you can use the menu to go to the choice other presentations, presentation resources. You will see a list of all my presentations. Click normalization beyond third normal form, and you will be able to download the slide deck that I am using now. However, enough about me. You don't really care a lot about all the stuff I do. The only thing you really care about is how to contact me if you have questions. Now, for the record, let's be clear, if you have questions now, please type them in the chat and Magnus will interrupt me and read the question to me and I will answer them during the session. But if you have questions later or if you have any questions about execution plans that you would like to ask, you can send me an email or you can reach out on Twitter and I will try to respond to you. So these are the only details about me, my person, that really are important to you. How to reach me by email or by Twitter. We are going to talk about normalization today. And a lot of people wonder, why would we even do normalization? And there are some misconceptions about normalization that I hope that I can get out of the world today with this session. For instance, many people will tell you normalization is boring, and it doesn't have to be. I think normalization and learning about normalization can be fun. The reason it is often conceived as boring is because academics are very good at making it boring. Why they do that, I don't know. They make their explanations as boring as possible, as if that is their target, instead of trying to make them a bit more fun. There's also people who think, yeah, but normalization, it's so hard. And again, I blame the academics who use weird terms that nobody else uses and very formal descriptions that are hard to understand. And it doesn't have to be hard. Normalization is, in fact, quite easy once you know the basics of how normalization works. And then there is the last misconception that normalization would not be important. Think of all the people who are coders and who like to design between air quotes their database using the code first approach. They don't design; they just write their code and generate a database based on their code, but that's not proper design, and that's often not properly normalized. And they say, well, it's not that important as long as we can store the data. But I hope that some of the examples today will show you that normalization is, in fact, very important. So what are we going to cover in this talk? We are going to start with the basics, and the basics includes an explanation of some key concepts and then normalization up to third normal form. Third normal form is for many people the cutoff point. There's a lot of people who say, yeah, third normal form is relevant, but anything beyond that is not important. Again, they are wrong, otherwise I would not present this session, and I hope to show that. But we start with the basics up to third normal form and the key concepts, and then we are going to talk about all the higher normal forms. And there's quite a few of them. There's elementary key normal form, Boyce Codd normal form, fourth normal form, fifth normal form, domain key normal form, optimal normal form, and sixth normal form. Try saying that 5 times in a row without breaking your tongue. Anyway, we only have 60 minutes. And normalization is hard. I said that's not true. If you go to college, you will probably spend a complete semester on just the key concepts and third normal form, and then another semester on the rest. We are going to do it all in one session if we had, let's say, 75 to 90 minutes, but we don't. We have only 1 hour, so I'm going to skip the part up to third normal form. After all, that's in the title, normalization beyond third normal form. 1 hour should be plenty for all the higher normal forms. Give me 15 to 30 minutes extra and I do everything. And yes, normalization is that easy. But let's start with the key concepts. There are some important terms that we need to define before we continue. And the first is the universe of discourse. The universe of discourse is a term that is used to, to declare a subset of the reality, or even of a virtual reality. And which subset? The subset as it is seen by the business. So, for instance, let's say you work for an insurance company. Their business revolves around everything related to their insurance policies, accounts payable, accounts receivable, their customers, public relations, whatever, anything related to an insurance is part of their universe of discourse. The latest football matches are not. That doesn't mean you cannot discuss the last football results at the water cooler with your colleagues, but you're not working at that time, and that part is not relevant to your work. For your work, you're going to stick to the universe of discourse, a subset of reality, only the part that the company cares about as the company sees it. And like I said, it can also be a subset of a virtual reality. Let's say you work for a game designer, and you create a database for their gaming platform. In that reality, death is a very temporal state. You respawn in 50 seconds, or in 20 seconds, or in whatever number of seconds, and maybe a maximum you have 5 lives or 3 lives, and you need to track how many lives you have. That is not our reality. In our reality, death is death. You're dead, period. So you look at the subset of the reality that is relevant to the business, and that includes even when the business has opinions that you disagree with, you still have to abide by their universe of discourse. Let's, for instance, look at the rather infamous example of the baker that refused to bake a wedding pie for a gay couple. Now, whatever your opinions on that, and let me assure you, I have some pretty strong opinions on that. Whatever your opinion on that, when you are hired by that baker to design their database, then you better make sure that your database implements the business rule that every marriage couple has to be one male and one female. Or if you disagree too strongly with that, if you are too principled, you refuse that assignment. You are not going to work for that baker and then implement something that they don't want to pay for. You may hate it, then either resign or hold your nose and do the work. They pay you to create a database to support their universe of discourse. And if they don't want to serve gay couples, I have my opinion on that. I might share my opinion on that. But in the end, they decide because it's their business. Now, why do we normalize? And if this were a live conference, I might even ask people in the room whether they have opinions. But I can tell you the most common answer I get is the reason we normalize is to prevent data in our database that is incorrect. Sounds right, correct? However, this is not correct. This is not the right answer. Let's say, and don't tell my wife this, but let's say that I sign up for a dating website. And among the things I need to upload is a picture of myself. So of course I find a recent picture that looks enough like me, like this, very representative. Of course, I need to make sure my webcam is disabled while uploading this. But if I upload this picture, then how can a database or an application or any part of that dating website ever realize that this is incorrect? Okay, with the advance of AI, you could have an AI bot compare this to the age, and if I'm foolish enough to specify my actual birth date, then this would fall through. But if I am consistent enough in my lies, then I could get a profile like this. And I would get lots of hits, and they would all eventually blitz off once we actually meet. And it turns out I don't actually look quite as good as that picture that I downloaded from the internet. So normalization cannot prevent incorrect data. However, what normalization can do, and what the purpose of normalization is to prevent data that is impossible, inconsistent, or in violation of business rules. Impossible data would, for instance, be when I specify that my birth date is in 2060. That would probably be a typo. But it's impossible because that means I wouldn't have been born yet. We don't want that impossible data in our database. Inconsistency would be my actual birth date with this picture. That would, of course, require some pretty advanced AI to detect, but it's possible. There's also other possibilities. And in violation of business rules, I would hope that most dating websites have a rule that you need to be at least 18. So if I specify as my birth date 2010, that will make me 14. It should not accept my application. All those kinds of impossible, inconsistent, or violating data should be rejected. And normalization is the goal of normalization is to get as many of those business rules implemented for free. And this is always done at a per table level. So the normal forms are defined at a per table level. And when we look at the eventual data, a complete data model or a complete database design, the normal form for that database is the lowest normal form of all the table level normal forms. So if you have all your tables are in fourth normal form except one that is in second normal form, then your data model is in second normal form until you fix that one table. So a functional dependency is the next term I want to talk about. A functional dependency means that there is a functional dependency of B on A. Column A determines column B if for each possible value of A, there is at most one value of B, but never more. So let's give some examples. Let's say we're doing a conference, a live conference. Then you might have a data model where you have the chair number where an attendee currently is sitting and their name and their birth date. Well, the chair number determines the name and the chair number determines the birth date. Those are two actual functional dependencies because if you give me a chair number, I can walk up in the room, find that chair, and perhaps it doesn't exist. Then I have no name and no birth date. Perhaps the chair is empty. Same, no name, no birth date. Or there is someone sitting there and I can inspect their badge and have one name and one birth date. Okay, some of you might now think, and what if I sit on someone's lap? But we are a technical conference, not that kind of conference, so that doesn't happen in our universe of discourse. Birth date, though, does not determine the name, because even at a small-scale conference with just a handful of attendees, it is at least theoretically possible that two attendees have the same birth date. So you cannot guarantee that you will never get more than one name for a specific birth date. So that's not a functional dependency. Now, there are some different terms used in the context of a functional dependency. So if there is a functional dependency of name on badge number, then you can also say name depends on badge number. Or you can reverse it and say the badge number determines the name, which is often written in a shorthand form, badge number, pointing arrow, name. All of these means the same, that there is this functional dependency, which is sometimes shortened to FD. Now, the examples I've showed so far are simple functional dependencies, but we can also have composite functional dependencies where, for instance, the combination of A and B combined determines C. That means that for each combination of A and B, there is at most one value of C. Returning to the conference example, if we scale up and have multiple rooms, then the chair number by itself doesn't determine the name anymore, because John might be sitting in chair 1 in room 1, but Melanie might be sitting in chair 1 in room 2. So if you just give me room 1, I might have two names. But if you give me the room number and the chair number, then once more, there will be at most one person sitting there, so at most one name. That is a composite functional dependency. Now, once you introduce those composite functional dependencies, you will also encounter cheaters. Badge numbers tend to be unique on a conference. So give me a badge number and I can tell you what the name of that attendee is. Now, if you give me the combination of a badge number and the chair number, I can also walk up to their chair, verify that the person sitting there has the specified badge number and give you their name. Again, it will never be more than one name. But this is a cheater because the badge number by itself already determined the name, and adding the chair number can't change that. If you already have the badge number included, then whatever extra columns you add will not change that. The badge number by itself already determines the name. So this cheating functional dependency is not really relevant. Now, you might think, how about composite the other way around? So what if column A determines the combination of columns B and C? Well, that is not really interesting, because if A determines the combination of B and C, then automatically we know that A determines B and A also determines C. So we always just split this into those individual functional dependencies. And the same if both sides of the equation are a composite. The left side remains composite. We cannot split that, but the right side can be separated into individual functional dependencies. Now, the last term I'm going to introduce is the candidate key. A candidate key is defined within a table, and it is defined as any column or any combination of columns that determines every other column in the table. So in this conference example, if you give me a badge number, I can find that attendee with that badge number, and I can tell you exactly one room that they are in now, or no room if they are in the hallway track, exactly one or at most one chair they occupy, and exactly one name, or no name if you gave me a badge number that isn't used. But it will never be two names. If you give me just a room number, I cannot give you a single badge number. I cannot give you a single chair. I cannot give you a single name, because most of the time there will be multiple people in that room. If you give me just a chair number, the same, you already see an example in the sample data. Chair number 24 is used by two people in two different rooms with two different badges and two different names. So if you ask me who is in chair 24, I cannot give you a single answer. But the combination of room and chair, we saw that before, that once more is just a single attendee. So I can go to that chair in that room and tell you, oh yeah, room A chair 24 is currently occupied by someone named Julie, and she has badge number 126. And there will never be two answers. Based on the name in the sample population, it might not be obvious, but you can imagine that it is definitely possible that there are two people with the same name, and they might even be sitting in chairs with the same chair number in different rooms, or they might be in the same room in different chairs. So name by itself or name combined with any other column is not a functional dependency, unless of course you combine it with badge number or with room and chair, but then it would be a cheater functional dependency. Now, if you look at the table, and we saw that in the example already, there may be more than one candidate key. And at that point, they have to do a kind of an audition where one will be selected as the prima donna. They get the lead, they get up to become the primary key. And just as in stage productions, the others that are good candidates for the role often are assigned alternate. They might take over if the prime is sick. Well, in tables, columns don't get ill, but you still have the one that is designed to primary, and the rest are the alternates. However, for the entirety of database design, the difference between primary key and alternate key is actually completely irrelevant. So the rest of this session, I'm just going to talk about candidate keys, and sometimes I'm just going to use them call them keys. Now I'm going to skip the parts on first, second, and third normal form. That was the part I don't have time for, and I go to the end of that part where I can tell you that the short description of third normal form is that every non-key column has to depend on the keys, the whole keys, and nothing but the keys. So help me God. This is a shorthand that I learned in college, and who didn't? Well, probably those who didn't attend college or didn't take database design classes. But this is the short summary, and the mnemonic for third normal form depends on the key, the whole key, and nothing but the key. Also, if you Google for Bernstein's algorithm for synthesis of a third normal form schema, you will find a very easy, it is described in scientific terms, so not easy at all. They make it as hard as possible, but once you dig through that, it becomes quite easy, a relatively easy way to create a third normal form schema based on a complete list of functional dependencies. This works functional dependencies. If you miss a few functional dependencies, or even one, or if you have one or more mistakes in your functional dependencies, then the schema that is derived from Bernstein's algorithm will, of course, not be correct because you gave it incorrect data. Okay, so we covered the key concepts. We skipped normalization up to third. It's time to start on all higher normal forms. Start with boys code normal form. I'm going to skip elementary key for now. I'll return to that, but I'm going to hop a bit to the right and then to the left because reasons. So boys code normal form. To understand boys code third normal form, every non-key column depends on the keys, the whole keys, and nothing but. So what does boys code normal form mean? Every column depends on the keys, the whole keys, and nothing. So third normal form only sets rules to non-key columns. Key columns can do whatever they want. Boys code normal form applies the same rules to. Let's look at an example. We have a database design here once more for a technical conference where we plan the session by a track code and the session number, and each of those sessions takes certain time in one of the rooms we use for our conference. And there are some functional dependencies that are quite obvious. The combination of track and session number, which in effect is a single session, determines the room and the start time, because a single session is just a single room. You cannot have the same session in two rooms. Well, you could stream the presentation to the other room. That is not in our universe of discourse. Our conference doesn't do that. And you also can't have the same unless you repeat it, but then typically you would still give it a new session code. Also, given a room and a start time, there can only be a single session in that. Imagine having two sessions, two different sessions in the same time. So you have this stage, and on the left side, I am jumping up and down and attention, while on the right side, Ground Fritchie is obviously getting your attention because he's a much would be amusing for 2 or 3 minutes, but I don't think you would learn what you intended to learn during that session. So we don't want that. And by the way, I didn't explain it yet, but the arrows you see in the schematic version of the table, those keys. So the arrow above track and session numbers means that there is a key on track and session number, and that key is there because all other columns depend on that combination. So we have two keys, each of them composite because of those dependencies. However, while this is a perfect design for a generic conference, I am working for a specific client, and they have some specific extra function business rules, and because of those business universe of discourse, two of these functional dependency cheaters. Why is that? Because this client has told me I want there to be a one-on-one dependency between track and room. All the are going to take place in the blue room. All sessions in room 605 high track. We like it that way. That's easier. An attendee who is only interested in personal development to just do 25 and remain there the entire day. That's a choice. Conferences don't need to be run that way, but the organizer can make that choice, and that makes null dependencies part of this universe of discourse. And now we have two functional dependencies depends on a part of a key, one of the two columns of a key. If room or track were non-key columns, this would violate third normal form. But they are key columns, and third normal form doesn't care about key columns. So there's nothing wrong with normal form. But in boys code normal form, those two functional dependencies violate the basic rules of boys code normal form. And at this point you might wonder, so who cares? What do I care? Why would I bother? It's third normal form. Third normal form is good enough. I read it on the internet, so it must be true. Well, let me tell you why you should care. Let's say you implement this third normal form design and create that as your database. Now someone edit screen and change the room for PD203 and reassign that session to room 605. That change would be accepted by the database. None of the keys we have identified are violated. The new population would still be valid. Sure, okay, no problem. However, this new does violate 2 business rooms. Suddenly, the room no longer determines the track because room 605 has sessions from 2 different tracks, BI and PD. And if you imagine that this is just a part of the population, that there are more PD sessions, but we reassign only this one, then track also no longer determines the room because one of the PD sessions is in 605 and the rest is still in 225. So we violated 2 business rules and the database didn't prevent it, even though it was in third normal form. But it wasn't in boycott normal form. This violation of a business rule was not prevented. If I had not skipped the part on the first 3 normal, you would already have seen that if there is a violation that is based on a typical fix is to create a new table for that functional dependency. So we're going to do that here as well. We're going to create a new table just for track and room, those 2 functional table, and this single table is created to third normal form and boycott normal form. It's just okay. Now, once we create such a new table, then we have to look at which the key. That's okay. And the other columns that we created in that new table have to be removed from the original table. Now, in this case, there's 2 keys, so we can choose. We can say then room can be removed from the left table, or we consider room to be the track has to be removed from the left table. There is no reason to prefer one choice over the other. In this case, let's say that I choose to remove. Now, if I remove that column, I have a problem because it's part of a candidate key. What happens to that candidate key if the room column is removed? It doesn't just become a candidate key over start time only, because we see in the population there's 2 sessions that both start at 4, and that's a valid population. So a key over start time only would not. What happens in this case is that there are some hidden extra keys. The keys I painted in the picture are the keys that are logical, that make sense, that we all understand are there. But if you use a methodic approach, you will find some other candidate keys that are in fact implied the one-on-one dependency between track and room. So there is for also a key on start time and track, and that implies the key on room and track. Because if you give me AD 10 o'clock, because AD determines the room, that will always be the blue room 10 o'clock. Combination of AD of track and start time is unique. Then by definition, the combination of room and start time is unique, because that one-on-one dependency between track and room. So even though we lose one of them, is still there, should also still be there, and we can safely remove the room column while still enforcing all the business rules, now including the business rules that track and room have a one-on-one dependency. The problem with BCNF is that there are cases where BCNF is impossible to achieve. So let's change the starting point of our BCNF example. Now you will see that in the sample data on the left, the DBA both in the ground room. What happened is that this conference had to scale down. COVID, less people, less budget, you know the thing. So they only could afford to hire 3 rooms, but they still wanted 4 tracks. Okay, we still want each track to be in 1 room only. track still determines the room, but room no longer determines the track because both the DBA sessions and the PD sessions. So that means that now the combination of room and start time determines track is no cheater, but the combination track session number determines room is still a cheater because track by itself already determines the room. So now instead of 2 violations of BCNF, we have just 1. Room doesn't determine track, so that doesn't violate BCNF, but track still determines room, which is a BCNF violation. Fix a normal form violation. You look at the dependency and create a new for those columns. And now we have just a single candidate key, so obviously it always has to be the that goes away. And yes, we still have this problem with this key. We still cannot just remove the room column from sessions starting at 4. And you might say, well, we still have this session on track, this key on track and start time. And yes, we still have that combination. But there is one weird thing now, a problem that we didn't have discussed, but we do have it now. I could change starting time of session DBA 305 to 2:30. This does violate the business rule. The PD sessions are both in the ground room. So now we have 2 sessions in the ground room that start. We have Erin Stellato talk about query store. Well, at the same time, someone, I can't come up with a name right now, is talking about personal growth. Again, amusing, but not functional. And the organizers don't want. If you look at the keys we have in the tables, it would be an allowed change. The database would allow this change, and the business rule that the combination of room and start session number is no longer implied by the database. We do not want that. So we do not want the room column from the left side table. But if we leave it there, then we have it. Because now I could reassign PD203 to room 605. And if I do that for just PD203, but not for the other PD sessions, business rule that track determines the room. Now we have one track that uses multiple rooms, which the business didn't. But again, this change that you see on the screen is allowed by the database that enforce our business rules. And the purpose of normalization was to enforce as many business rules. So we don't like this either, and there is no perfect solution. However, there is a sort of good enough solution. And that is a foreign key that is a bit weird. So the combination of track and room from the left table can be declared as a foreign key that must exist in the right table. The weird thing there is that the commanded key in the right side table, and while MySQL will allow this, most database systems do not even allow this. You can get around that by key constraint in the right hand table on track and room combined, which is of course redundant because track by itself is already a key. And uses, technically speaking, a BCNF violation in that second table. It might even introduce a second normal form violation if there's more columns in the right hand table. Think of that extra primary key as a technical trick to work around the BCNF is not achievable. Then what I do is I say, let's pretend it's not there. I only had to declare it because the DBMS wanted it. So this is a way, while the schema is still not in BCNF, and if you use this trick, it might even violate second normal form, we have the database regarding all our business rules. So I always would use in cases like this. However, like I said, these cases are extremely rare. I haven't ever run across any real world scenario where I had to use this trick, and I had to have thought into coming up with an example for this presentation to even show this, because in reality it hardly ever happens. But if you do, then you now know how you can still make the database enforce all the business rules, even though BCNF is not possible to achieve. Now we're going to take one step back and we're going to talk about elementary key normal form. So elementary key normal form sits in between third normal form and Boyce Codd normal form. Third normal form, every non-key column depends on the keys, the whole keys, and nothing but the keys. Boyce Codd normal form, every column depends on the keys, the whole keys, and nothing but the keys. So what is elementary key normal form? Every non-elementary key column depends on the keys, the whole keys, and nothing but the keys. Well, that's a great definition if you know what non-elementary key means. So what is an elementary key? An elementary key is based on elementary dependencies. An elementary dependency is a functional dependency that abides by an additional rule, namely that if the combination of A and B determines C, then C shall not determine A, nor shall C determine B. If C determines one of those two columns, then this is still a functional dependency, but it's not an elementary dependency. If C does not determine either A or B, then it's an elementary key. An elementary dependency, sorry. An elementary key is then any key that implements at least one elementary dependency. So if the combination AB determines C is not elementary, but the combination AB determines D is elementary, then the combination AB can still be an elementary key. But if the combination AB only determines other columns that are all not elementary, then AB is still a candidate key, but not an elementary key. Now, what does that mean? That means that elementary key normal form is the same as third normal form, except for columns in non-elementary keys. Or you could say it's the same as Boyce Codd normal form, except for columns in elementary keys. This is the highest normal form that is guaranteed achievable. Like I said, Boyce Codd normal form is not guaranteed achievable. There are rare cases where you can't get there. Elementary key normal form can always be achieved, and in fact it has been proved that Bernstein's algorithm for synthesis of a third normal form schema, elementary key normal form was described later, but Bernstein's algorithm actually results in a schema that is elementary key normal form. Now, is this relevant at all? Not really. Because if you have a universe of discourse where you have such an unsolvable Boyce Codd normal form violation, then, well, yeah, you can create a database design and say it's still elementary key normal form. Yeah, nice. But remember, the problem with BCNF was that the database allows business rules to be violated. We don't want that. Relabeling it elementary key normal form doesn't change that. You need still to work around this limitation of your database schema using either the trick I described with the weird foreign key, or by enforcing business school rules in the client or in triggers. So let's move on to fourth normal form. Here I have the schedule for an Ask the Experts corner. Every day from 12 to 1 there is during lunch a corner where you can ask experts about certain topics. And when the conference was set up and the schedule was made, people could sign up as an expert for Ask the Experts, indicate on which days they want to be there and what subjects they talk about. And if you look at the data here, what people often overlook is that every row in a column actually represents information. It represents facts. So the top row, where you would say day is Monday, expert is Erland, subject is design, is actually a representation of the information that on Monday you can ask Erland questions about design. Now, the interesting thing here is that this fact actually is this sentence is actually a combination of multiple facts. On Monday, you can ask Erland about design. That implies two shorter facts. You can ask Erland questions on Monday, and Erland knows what he's talking about in the design area. Two facts. On Monday, you can ask Erland questions. Erland knows about design. And now it becomes interesting. Because yes, from the top fact, on Monday you can ask Erland about design, you can always imply those two new facts. But how about the reverse? Can you also, when I tell you, you can ask Erland questions on Monday and Erland knows about design, can you then infer that you can ask Erland about design on Monday? You might say, yeah, that's obvious, but perhaps it's not. Perhaps Erland has indicated, no, I do not want to talk about design on Monday. Why not? Well, I don't know. Perhaps he doesn't like Mondays. I don't know. But if we allow Erland this freedom to pick and choose what subjects to talk about on each day, then even though you can ask him questions on Monday and even though he knows about design, you cannot infer that you can talk about design to Erland on Monday because, like I said, maybe he doesn't like Mondays and he refused that topic. In this case, if this is the universe of this course, then fourth normal form is not violated. And the database, the table you see on the left-hand side is perfectly designed. There's nothing wrong with it. However, if the organization says, Erland, oh, come on with your pickiness. You say that you know about design. You say that you're here on Monday. You are going to answer those design questions. Stop being so picky. That's your problem. So if we know that you are here on Monday and that you know about design, then yes, you are available to answer design questions on Monday, period. If you don't want that, well, then just don't show up as an expert on Monday. That means you also are not going to talk about tuning on Monday. Or remove design from your badge and talk about tuning only on Monday and Tuesday. We don't care how you do it. One of those two is okay, but you cannot just refuse a single topic on a single day. In that universe of discourse, fourth normal form is violated because, as you see, a single change requires us to remove or add multiple rows. A single fact is not represented by a single row. They are represented multiple times. And as soon as you represent facts multiple times, you can violate business rules. For instance, by removing just the top row, which violate the business rules. Again, how are we going to fix that? Well, we have two fact types. One on day, you can ask name questions, and another fact type, name knows about subject. So those are two tables, and we should have implemented them as two tables. And once we have these two tables, we can actually get rid of the original table. Now, this table might still be interesting. We still might want to print this in our schedule or put this on our website, but we don't have to store this table. We can simply join the two new tables together, and that will always reconstruct the left-hand side table because Erland is not allowed to refuse design on Monday only. So scientifically speaking, a table is in fourth normal form if it is already in Boyce-Codd normal form and there are no multiple dependencies between subsets of columns. So what is a multi-valued dependency? Well, a column A multi-determines a column B, written with a double arrowhead, if for each possible value for A. Now for a functional dependency, the rest of the sentence would be there is at most one value for B. Here, the rest of the sentence is there are 0, 1 or more values for B. Well, that is quite obvious, regardless of values in the other columns. And that makes it interesting. So in a conference, give me a specific session and I can not give you a single attendee, I hope, But I can give you a list of attendees, and I can always, and that will be all the attendees that are there. But for that same session, I could, sorry, that was a wrong click. For the same session, I can not guarantee the same for a presenter. So who attended the session presented by Hugo? Well, I cannot give you a list because he actually presented two sessions and they didn't draw the same set of attendees. So here the answer, which attendees listened to Hugo, depends on which of the sessions I presented. So now the set of values for attendee is no longer independent of other columns. You can also have composite multi-value dependencies. So for instance, if you ask who attended the session normalization beyond the third normal form, if your universe of discourse is just SQL Friday, that would already be a multi-value dependency. If your universe of discourse is larger, then the answer who attended the normalization beyond third normal form depends on whether you talk about today, SQL Friday, or whether you talk about end of June when I present this same session for data grillen, or whether you talk about SQL Nexus 10 years ago. The answer will be different. So now a value in another column changes who attended this session. But if you specify the conference plus the session, then you once more have a list of attendees. So this is a multi-valued dependency. And here, other than with a functional dependency, composite the other way around is relevant. If a column A multi-determines the combination of B and C, then it does not imply that it multi-determines B or multi-determines C. If A multi-determines B and A multi-determines C, then by definition it also multi-determines the combination. But there are cases where it multi-determines the combination, but not the individual columns. Like, for instance, here, the case where Erland is allowed the freedom to not talk about design on Mondays. Expert multi-determines the combination of day and subject. Give me the name of an expert and I can give you exactly what days, what subjects they talk about. But expert does not multi-determine the day. On what days can you talk to Erland? Well, that depends. If you want to talk about design, you have to be there on Tuesday. If you want to talk about tuning, you can ask your question to Erland on Monday or Tuesday. Does expert multi-determine the subject? Again, no, because on Monday, Erland talks about tuning, on Tuesday on tuning and design. So in both cases, the answer which days or which subjects are related to the expert depends on more columns than you give here. However, experts does still multi-determine the combination of day and subject. Those are all the columns in the table. I already said functional multivariate dependencies are by definition there for all the columns. Only multivariate dependencies that do not cover the whole table are fourth normal form violations. Those do not exist. So in this case, fourth normal form is not violated and this table is correct. But in the case where Erland has not given this weird freedom to not talk about design on Mondays, now expert does multi-determine the day and expert does multi-determine the subject. So now this three-column table on the left-hand side does have two fourth normal form violations, and it would be incorrect. You should replace it with the two smaller tables. And you saw from the example I showed how fourth normal form violations work, why it is relevant. If you don't make this change, if you leave the original three-column table, then you can remove a single row and violate a business rule, and your database doesn't work for you. And you want your database to work for you. Let's move on to fifth normal form. When I told you that the fact on Monday you can ask Erland about design implies two other facts. On Monday you can ask Erland questions and Erland knows about design, I actually was a bit incomplete because there's a third fact you can infer, namely that on Monday you are allowed to ask questions about design. What if the conference organizer doesn't like Mondays? What if the conference organizer can say on Monday nobody will talk about design? Then, of course, Erland is banned from talking about design on Monday, but so is Oliver. Again, a single decision by the organizer, a single change affects multiple rows. We have a problem here. This table, in this universe of discourse, with these business rules, still has no multi-value dependencies. At least none that are shorter than the table itself. So it is still a fourth normal form design. And yet we have a problem. We have a situation where deleting a single row might violate a business rule. So while we didn't violate fourth normal form, we still do violate fifth normal form. Fifth normal form means that in this case, because we have three facts that are relevant, we have to create three new tables. And once we have those three new tables, we can remove the left-hand side table. So let's move to the scientific definition of fifth normal form. A table is in fifth normal form if it is already in fourth normal form. You saw that coming, of course. And then the next additional rule is that there shall be no join dependencies unless applied by a key. What the heck is a join dependency, Hugo? Great question. Let's see if that's on the next slide. Yes, it is. A join dependencies means that let's take a table. Let's break it up into its subparts by just using column combinations and populating those subparts by queries from the original table. Let's then drop the original table. Let's now join the new tables together and see what the result is. If the result is always the table we just dropped with the exact same population, then there is a join dependency. If we allow Erland to not talk about design on Mondays, then there is no join dependency, because now the left-hand table would still result in the same right-hand tables. Monday is still, Erland is still an expert on Monday. Erland still knows about design. Design is still an allowed subject on Monday. But joining it together would reintroduce the row we just removed. But if the organization can choose to remove all design experts from the Monday, then splitting the table would remove the row that says you can talk about design on Mondays, and joining them back together would once more reintroduce the original table. So that would once more be a join dependency. That was fifth normal form. Time to go to sixth normal form. Sixth normal form is similar to fifth. Fifth normal form says no join dependencies unless implied by a key. And I talked a bit over that unless because sixth normal form removes it. So let's talk about that unless implied by a key in a bit more detail. Let's look at a new universe of discourse. Here the sessions are once more identified by track code and session number, but in this case they are not split. That is a discussion I would have had if I had discussed first normal form, that depending on the universe of discourse, 8205 might be an atomic value or it might not. Here 8205 is an atomic value. And the session code determines the topic, determines the first name of the speaker, and determines the last name of the speaker. Again, first name and last name might be an atomic value when combined or might not. Here, they are not atomic values. They are individually relevant. So that's why we have these columns. Is there a join dependency here? Well, yeah, it's quite obvious because each of the columns is determined by the session that we can just split it up into three individual tables, join them back together and get there. And that's quite obvious because session is the key here. If you do that with a key column, it's obvious that you always get back the original table. So obvious that for fifth normal form, they said those obvious join dependencies are irrelevant. But for sixth normal form, they said, let's also look at those join dependencies and favor the three shorter tables over the single combined table. Now, what is the benefit there? The benefit is that, let's say that the original table allows null values. The proponents of sixth normal form hate null values. They believe that null values are a mistake. Now, if you split this table with the null values, you lose some rows. You don't have to store them as null values in the shorter tables. You can just remove them. And you can still join it back together using outer joins, of course, and reconstruct the original tables. And now on the right-hand side of the slide, you see that you indeed do not have null values. Does that solve the problems with null values? No, because typically speaking, you would still have to join everything back together and get your null values back. Actually, the people who complain about problems with null values do not realize that in fact they are complaining about problems with missing data. But missing data is a reality in some universes of discourse, and you can dislike it, but you still have to deal with it. Now, sixth normal form has some other problems too. In the table on the left-hand side, if I change Steve Jones to Tim Jones, I would likely get a foreign key constraint error because the combination of first name and last name has to exist in the speakers table. But if I use sixth normal form, then the same change could be made in the right-hand side table. And because first name and last name are in separate tables, I cannot implement a foreign key to prevent this. So I actually, by getting rid of those null values in the storage but not in the code, I have introduced new options to violate business rules that I don't want. I really do not like sixth normal form for this. So how to solve this? Well, you could say, okay, first name and last name belong together, so let's keep those in the single table and not split those, but still split the topic off. Only keep first name and last name together because they operate as a unit in a foreign key in this case. And that is optimal normal form. So this will be the optimal normal form design. Optimal normal form is a normal form that is based on certain fact-based modeling methods, such as object role modeling or NIAM, that were introduced and designed in the 70s and 80s and for some reason never gained much traction. I personally am very fond of them, but they never gained the traction they deserved. However, based on those methods, they use fact types, and some of those fact types are and they use elementary fact types. This word elementary has nothing to do with the elementary functional dependencies of EKNF. So it's just an English word used for something else. But those modeling methods work based on elementary fact types, and every elementary fact type simply becomes a table, and then you have optimal normal form, which is mostly sixth normal form, except in situations where there are composite foreign keys or composite alternate keys, and columns have to remain together for that reason. As far as I know, there has never been research into an academic foundation for optimal normal form. And just like sixth normal form, optimal normal form also results in way more tables than we need. Modern RDBMSs are not designed to optimally handle that. So even if you like optimal normal form or like sixth normal form, your database design in a mainstream DBMS will not perform properly if you use those normal forms. I know that there are research projects for database design, database engines that are optimized to work with sixth normal form. They might work well, but they are not mainstream. They are just research projects. So in our practical day-to-day work, both optimal normal form and sixth normal form are irrelevant. You don't want that bad performance. The last one I'm going to talk about, and I realize I'm 1 minute over, so I will be a few more minutes over, but I'm going to finish this, is domain key normal form. And I'm going to go quite fast because this is also a normal form that has no practical relevance. Domain key normal form is in its description not based on dependencies, but it's based on domains, keys, and constraints. A domain is a list of all the values that are allowed in a column. For instance, all the values in a gender code, or all the valid values in a report score in a school system. Keys are the candidate keys we already know, and the constraints are basically the business rules. So DKNF is defined as every constraint, every business rule must be implied by the keys and the domains. Basically, this is what I started with as the goal of normalization. All the business rules must be implied by the keys and the domains. And that's great because, well, we get there. There's one more thing. It has been found that if you can prove that a design is in domain key normal form, then it is proven that it has to be in fifth normal form, which also implies all the normal forms. There's no scientific proof for optimal normal form, but I personally think that DKNF also implies optimal normal form. However, DKNF does not imply sixth normal form, and sixth normal form does not imply DKNF. So here we do not have a strict hierarchy between DKNF and 6NF. Now, why is DKNF relevant? Domains are declared. You can just declare a check constraint and the database will enforce it. You don't need to do any code for that. Keys are declared. Once more, the database enforces it. You don't need code. If you need other constraints, then you will need code to enforce them. Okay, foreign keys are an exception here, but we are talking about the table level. So foreign keys are a bit out of scope for this discussion. But all other constraints need to be enforced by code. And code is expensive for the business. The business doesn't like code. So if you can enforce all constraints by domains and keys, you save a lot of coding. However, DKNF cannot always be achieved. Sometimes it's simply impossible. Let's say we run a large conference and we give the presenters, we pay the flight of all the presenters and their hotel. That is, of course, a cost issue. So to save some cost, all the presenters have to deliver at least 3 sessions. Well, think of the database design of the table where the presenters and their sessions are listed. That means that every presenter needs to be in 3 rows. There is no database constraint that can enforce this. So it's impossible to achieve domain key normal form in this case. Sometimes it is possible, but it requires extra tables. Let's say that we have, for whatever reason, some specific extra rule that applies to male presenters but not to female presenters. You might be able to enforce that by using subtables, a table for all presenters and a table for male presenters and a table for female presenters. But some columns in the all presenters tables and some columns in the male presenters or in the female presenters tables. Yes, then you would have domain key normal form, but once you query, you will have more complex code because you need to join all that together, and queries are code too. And again, code is expensive. So domain key normal form might not always be achievable, and even when it is, the code you save is often paid for by introducing other new code. And that makes domain key normal form interesting from an academic point of view, but not relevant in our day-to-day work. So what did we talk about today? We talked about first, second, we skipped first, second, and third normal form, but third normal form implies second and second implies first. Or in other words, second normal form is defined as table must be in first normal form and something else, like all the other definitions. Boycott normal form is built on top of third, fourth normal form on top of boycott, fifth normal form on top of fourth, and sixth normal form on top of fifth. But we also talked about elementary key normal form that sits kind of uncomfortably between third normal form and boycott normal form. We talked about optimal normal form that hangs between fifth and sixth, and we talked about domain key normal form. That are all the normal forms, and we talked about all the higher normal forms, and I hope I convinced you that it is not hard, it is not boring, and it is relevant, at least up to fifth normal form. Are there any questions at this time?
There are. Let me check in the other chat. No, no questions on YouTube and no questions on Teams. So that either
So either I was entirely clear or everyone has fallen
exactly.
asleep.
But there are people who
Yeah.
joined during the call, and there are still a lot of people who are here. So I don't think people. I mean, the equivalent of falling asleep on a Teams call is to leave the call, I guess. So and people did that.
Unless you actually really fall asleep,
True.
of
I
course.
have been in a business meeting. We were testing something with a client. We had worked, you know, long weeks, and we were finally doing the final performance test together with the client, and the person who started and called to the meeting fell asleep, and he snored. And since he was the organizer, we couldn't mute him. So that was interesting.
Yes. Okay, well, my email is on the screen. My Twitter handle is on the screen. So if anyone has questions later that didn't come up now, or if anyone after watching the recording has questions, feel free to reach out. I also welcome questions about query performance and execution plans, but I think most people already know that. This concludes my talk. I did go over a bit, so perhaps doing all the normal forms in 1 hour was a bit too ambitious. We still don't need an entire semester for it. It's not that hard. Thanks for
No,
your
and
attention.
I agree, and
And Maurits,
I
thanks
think
for having me.
it's a really good idea to try to, how should you say, popularize the topic, because I agree. I took database design in university, and it wasn't fun, and it was very theoretical. It took maybe 6 weeks until
Hmm.
we touched a computer, and no,
Yes, academics are good at making even the
yeah,
fun stuff
true.
boring.
I'm gonna stop the stream to YouTube, so